Okay, let's look at question 5. Hydrogen gas and iodine react to form hydrogen iodide at an elevated temperature represented by the equation. Write the expression for the equilibrium constant Kc for this reaction. So this is not too difficult of a question. As you know, Kc, the equilibrium constant, is the concentration of products raised to their mole ratio divided by the concentration of reactants raised to their mole ratio. And these are all gases, so they do have concentration values. So for this equation, Kc equals concentration of Hi squared divided by concentration of H2 times concentration of I2. All right, the next question. Hydrogen and iodine are added to a previously evacuated container and allowed to react. So at a certain time, the reaction quotient Q is 0.67. So that's actually really important. If Q is 0.67, what that means is I have more reactant than I do product. Okay, so make yourself a note or just mentally make a note that this value means I have more reactant, because when K is less than 1, my denominator is a larger number. So my denominator is this reactant value. I have more reactant than product. And the ratio is actually, it's like 2/3, right? So 0.67. So the following particle diagram shows you an incomplete representation of the system. So what I'm showing in this diagram, these are all reactant molecules. I have 2 iodine and 3 hydrogen. So I have reactant molecules shown only. So show me the number of Hi molecules needed in the diagram so it represents the system properly. All right, well, if I do a little bit of mental math, so Q is going to be 0.67, so it's like 2/3 ratio. So my product is going to be, I don't know what yet, I have to figure that out. But on the reactant side, what I have is I'm just going to use like these raw numbers here. I have 3 hydrogens and I have 2 iodines. So my denominator is 6. So what I need to know, what I have to have on my numerator to get this 0.67 value is I need to have 4. But because if you go back up here, Hi is squared, I'm going to need to draw 2 Hi molecules to get the ratio Q equals 0.67. And we're going to try to draw it relative to the sizes we see here. So the iodine radius is bigger and the hydrogen radius is smaller. Okay, so that's one, and then we'll put another one here. Okay, and that's the answer for question B. Tricky question, more difficult than it seems, that molecule one. And then this question here, let's move on. Okay, so basically we have to look at this graph. A student monitors the number of moles of Hi over time, that's the product. Hypothesize an experimental change that could have been applied to the system in a rigid container at time t to result in more products produced. So remember, the equation is like this. Now, based on this graph, the moles of Hi went up. So at this dotted line, we have some sort of Le Chatelier stress. Now remember, the stressors are concentration and volume. Volume and pressure are the same, catalyst and temperature. And what I know is that based on whatever stress I put there, it shifted to the right because this product went up. Okay, the product increased, which is what I see here on this graph, after I applied the stress. So what could the stress have been? Well, it could be a few things. So it cannot be anything to do with pressure because we have the same number of moles on each side. There's 2 moles on the left and 2 on the right. So if we go back to the equation up here, there's an additional information. This is really important because if it tells you delta H is negative 12 kilojoules per mole, what I know is that the heat is on the product side. So to get my reaction to shift to the right, I could have done this. I could have decreased the heat or the temperature. So that's one possibility. And it says here, assume that the student did not add more HI gas themselves, which is fine. We didn't make that assumption to begin with. So we can say that one reason for this is that the heat or temperature was decreased. If you remove that from the system, that's going to cause the system to replace the heat by shifting to the right. Okay, now another possibility for this answer is that you could have added more of each of these reactants. Now, sometimes on these graphs, when you add a reactant, it'll spike up, like it'll, like your Le Chatelier stress will show that, actually, sorry, it's only showing the product here. So because it's not showing me the reactant, yeah, another possible answer is that you could have added a concentration of H2 or iodine. So these could have gone up. If you added the reactants, there's more collisions on the left, which will shift it to the product side. Okay, and then finally, let's answer the last one here. It says here the question, after equilibrium is established, the mixture is transferred to a larger container at a constant temperature. As a result, would the moles of HI increase, decrease, or remain the same? I kind of already alluded to this when we were looking at this graph. So when you're dealing with gases, and if I change up the temperature is constant, if I change up the volume, the rule for this is because gases like to fill the container they're in, when you increase the volume, the equilibrium will shift to the side with more moles. Now, but in this equation, I'll rewrite it here. I have the same number of moles on each side. There's 2 moles on the left and 2 moles on the right. So there is no shift. No matter if you decrease the volume or increase the volume, nothing's going to happen. So we're going to say here that the moles of HI, this is the answer, remains the same. Again, you can reword this nicer by matching it on the answer key, okay? And the reasoning is because it's kind of what I wrote up here, because when you increase the volume of a container, you have to shift to the side with more moles, but since we have the same moles on each side, there will be no net shift. Okay, so again, the answer key is not exactly worded exactly as I'm saying, so you can take a look online to see what they said for their wording, since we have the same moles on each side. Okay, that concludes question 5.